Hello, everyone. Welcome to another episode of the Day Zero podcast. I'm Spectre. With me is Z. Has been a little bit of a quiet week, but we do have a few things to talk about, starting with the fact that Z and I are going to be giving a training. So we've been looking to do trainings for a little while. It's actually been like a couple years. We've been toiling around with wanting to do trainings, and we finally have one set. So at Hardware.io USA, we are going to be giving a training on attacking hypervisors. The title of it is Attacking Hypervisors from KVM to Mobile Security Platforms. So KVM is going to be the main focus for like the first day or two. It's a little bit easier to look into where it's open source, and we've talked about it a couple times on the podcast. But we're also going to be covering some security-focused hypervisors like Samsung's RKP for mobile and Huawei's hypervisor enforcement. As well as touching on like Hyper-V and even the PS5's hypervisor a little bit. So if this is a training that sounds interesting to you, check it out, read through the outline and everything and see if it's something that would interest you. And, if you work at a company that's willing to pay for trainings, maybe that's something you could leverage, and we'd love the support. We figured we'd shout that out really quick.
Yeah, it's nice to actually get something that will hopefully be able to do this time. We did have a prior training accepted elsewhere that ultimately didn't really work out. And yeah, in terms of the actual content there, like, I'm excited to give it. It's something like, especially looking at the looking at the security hypervisors in general, I don't think is well covered in a lot of training. But we'll still be starting off from just like more hypervisor fundamentals. We're just kind of walking with the focus towards where they're used for more security enforcement and some of those different uses of it, rather than more like desktop usage of hypervisors or something like that.
Yeah. And just to clarify on the dates here, this will take place at the end of May. So it's the 27th to the 29th. It's a 3-day training, and it's a full 8.5 hour per day session. Well, there's breaks and stuff, but that's the time slot. So yeah, once again, if this sounds interesting to you, or if you know anyone who might be interested in this, yeah, please feel free to link it out. All right, so we can get into some of our topics. So the headlining one, and one that's seen a fair amount of attention, it is a little bit older, but it is called Keyhole, and it is about bypassing Windows licensing checks. So this is specifically for the Windows Store, and it's due to a logic bug in the client licensing platform, or CLIP. So where this is Windows, this bug did require some significant effort to even begin to find, because of the fact that it is closed source, but also for their DRM stuff, Microsoft actually does some obfuscation too, which isn't too common that we've seen with like coverage of Microsoft things before. So they have their own proprietary obfuscator called Warbird, which is leveraged here. So a fair amount of this post goes into the reversing and background of trying to audit CLIP. They were able to get a little bit of help because, for whatever reason, even though this is obfuscated, Microsoft servers had symbols for clipsp.sys, which is what Clip used for talking to the secure processor. So that managed to help out a little bit too. But the main thing that they looked at were these license block binary blobs, which contain tag length value blocks followed by a signature as a footer. So that would sign all of the TLVs that came before it. The main problem, though, is that any data that comes after that signature block just isn't checked, because of how their scheme works with the TLV format, any tags that come afterwards will override ones that came before. So you can override previous TLV blocks with ones that come after the signature block, and they'll just kind of be accepted through. So yeah, that's a really cool bug, and it's another demonstration of how crypto can be hard to use effectively, especially when you try to use it in this way as a footer and you don't verify that it actually is the footer. You can run into a lot of problems with that.
Well, it's not even just the fact that it's a footer. Like, what you could imagine this code doing, and I'm not sure exactly what the underlying code is doing here, but you could imagine this is basically just iterating over all the blocks. It gets this type of block, matches that up, puts the data, like parses it, whatever. And so eventually gets the CC block, which is the one containing the signature. General practice, put that at the end, and it's going to, just kind of track, we've seen all of these things, and therefore, now check it. And so using that logic, you just forget to like exit after that case, and you keep iterating. And you kind of hit that. And I mean, you could have similar, or you do have similar issues anytime signatures are used where it's a matter of how are they determining what information is supposed to be is protected by that signature.
It's signed, yeah.
Yeah, like that happens regardless. Like if it's a footer or not, it
Well,
happens.
the reason I phrased it like that is if they had checked that the last block that provided was the signature block and was truly a footer, then this issue would have been prevented. Even if they did that iteration and exited out early, right? So,
yeah, I just mean that well, if they exit out early, that would be the same as ending when they got the signature block. All I mean is like
true.
this bug happens. Like we've seen it in the SAML bugs from last year, I feel like, or maybe it was a couple years ago now. Like the SAML issues where it was XML parsing and basically just trying to when a signature is included in the data that's kind of being signed, you have this challenge of determining what data needs to be protected and what data isn't. Like it's just a challenging area in general and something that's usually worth exploring and playing around with a bit because you can make all of these sort of bugs.
Yeah.
Including this one, which is a fun little case of, they kept processing after the signature and you can just add more data. And that wouldn't necessarily be an issue if it didn't override the data also. Sorry, you were saying something?
That's good to like emphasize as well. But I was just gonna say this is also the kind of bug where it would be difficult to find just like fuzzing or something. Like it is one of those sort of deeper bugs where you have to look at how the scheme works and what's actually going on to really think about this as an attack path.
It doesn't cause
which always makes for interesting bugs. Yeah. The side effects are subtle.
Yeah, so. I guess I say it doesn't cause a crash, but actually, so they collided on this bug. The author here, they found it right around the same time Talos did, where Talos also put out a post. But this is the one that actually got my attention. I guess Spectre saw the Keyhole post first. I saw this one first, but they both kind of deal with the same thing. We have the same deobfuscation bit. They talk a bit more specifically about how they use the Qling or Qiling. I'm not sure how you're supposed to say that framework.
I think it's Qiling, but yeah.
Yeah. Either way, fun little tool to know about. It's a little binary emulator that you can use to kind of run. Well, there's a lot of ways you could use it, but you could run like very small, just like copy binary out of code and run that, give it registers or whatever. Or you can give the framework actually adds on being able to run like a small little elf or some other parsing there. Anyway, that's what they end up using. They have a few more details, but not a lot more details about how they did the deobfuscation. They mentioned using Qling, using that there, but the other thing that they go into is they actually found their bugs. They could get an out of bounds read where, depending on these types, it would, in a couple cases, just assume the size. So it would assume something would say like 2 bytes. And if you didn't actually send 2 bytes of data, they would get like a 1 byte out of bounds read out of that. They were able to turn that into a out of bounds write also. They did not go beyond that, but they did get into a little bit of memory corruption there. And I guess there was a Hexacon talk about it, which I started watching or listening to, but I didn't finish, so I can't really comment on that. But I can say that title just doesn't really do it justice, because saying, what the hell is Windows Clip Service? If I'm scrolling through titles, I'm just going to think this is somebody who did some reverse engineering on a random Windows service. And since I don't do Windows, I'm not going to check it out. But the bug does seem a bit more interesting than that when you actually understand. Now, of course, it's probably in the abstract, but I judge a lot of, books by their titles in a sense. I just scroll through on the basis of a title. That's not really all that important. It's just, I kind of noticed because we were talking about some of the Hexacon talks recently, and this obviously was something we did not mention at all.
It is kind of interesting seeing the two approaches where it's like, the first post that we talked about was more interested in the DRM bypass and bypassing those signatures. Whereas the Talos one is more about seeing like, okay, now that we can bypass signature validation, is there some memory corruption issues that can be taken advantage of? You kind of do have those two different like frames of mind for looking at it, which I thought was cool. So yeah, I guess we can move into some of other topics. So Z, you would notice this drilling at the redirect URI and OAuth post by Vorvex, and I'll let you take that one away.
Yeah, and there isn't a lot to bring out of this post. It talks a little bit about redirect URI and OAuth. Fundamentally, I don't actually think the issue is the redirect URI, or it is, but not in the way they make it sound. When I think of OAuth and redirect URI, I am thinking of the redirect URI that is used as part of the actual OAuth protocol. As you're crafting the link that goes over to the auth provider, you provide a redirect URI, so that the auth provider, once it does its thing, validates the user, gets information, whatever, gets the token, and it's sending that back. It's going to send it back to the redirect URI. That's where it's going to send the user to. And usually these providers are all going to do some fairly strict checking on that and some limits on where that can be sent back to. And so in terms of actual attacks, most common things like having an open redirect. So you could use a valid redirect URI, open redirect on like a valid redirect URI, so that you can try and steal the token. And they call that out here as, one of the attacks there. And then they kind of make it sound like a lack of state check is going to be sorry, that's not phrased too well. Ultimately, the bug that they found here is just that the state value was containing a separate redirect URI that their application happened to be redirecting on also, but because that redirect URI, like the state isn't being checked by the provider, so it doesn't have the same security, and of course, when the website doesn't check that, they're able to abuse that as though it were a redirect URI and basically get another redirect. It did take a little bit of effort. They end up using like that classic putting a @ sign in there to have it appear to basically match some of the checks before it does the redirect, but still, it ends with attacker it parses out, I guess I should say, to the expected domain, but because of the and when things happen, browser it's going to go over to attacker and not redacted. So they use that little trick, but the main problem here, I want to call it a problem. The main smell is when you see state being overused, putting a lot of information in there. That's kind of the main smell that I'd look for on something like this. I struggle with saying that because it is becoming an increasingly common practice to actually put a fair chunk of information in state rather than just using it as like an anti-CSRF thing. It is or being used like a random nonce, basically. Rather than being used like that, it is being used with a lot more information. And maybe I should read the spec on how scope is actually supposed to be used before I make any claims about not liking that, because I feel like perhaps state is supposed to store some type of state information. In fairness, like it's called state, so maybe there's more of a reason behind that. I just know from like my past experiences with that, when you start seeing a lot of information getting stored in there, it starts feeling like, maybe this is some sort of misused value to me, and thus a place worth looking more into. And in fact, in this case, see like a redirect URI, that's immediately going to get my attention as like, are they doing the proper validation there? And of course, they weren't in this case. So yeah, fundamentally, pretty easy issue here. It's that state containing too much or containing a separate redirect URI that isn't getting the same level of treatment that the normal redirect URI was. The only thing is, or the one thing I kind of take issue with, beyond just this very weird title image, can I just call that out? Like, what in the AI is this?
It's very weird seeing words that you can't read because they're not actual letters.
Yeah, well, it's like you could almost read everything, though. Like, that's the thing.
Yeah.
Because, like, it's all this, like, OAuth flow things in there. There's this weird little... It's just, like...
URI, yeah.
Yeah, like, I don't know. I get it where some images have the weird AI background. Just this one feels like you could have easily recreated this in any sort of graphing program and been like, okay, there's a decent little image. Although this flow doesn't quite see... Like, it almost seems like they're doing the OAuth flow. but not. Or actually, I was going to say but not as I highlight the redirect URI twice, but I guess in a sense it's actually accurate. I don't know.
Yeah.
It's again this is kind of like where I was commenting on the title of the last post, or well, of the talk with that
Of the
last
talk, yeah.
post. Yeah, it's the same deal. Like that is purely just me nitpicking here, and it's not something that makes any difference whatsoever to this post. Like you're not losing out on something because of that image. So yeah, I mean the one thing is like I feel like that redirect URL they're actually abusing isn't part of OAuth, but it is part of the state, so whatever.
So I was gonna comment, like, regardless of the spec or what the docs say, I feel like you're like not liking sticking everything in the state is kind of a fair opinion to have, because we've seen multiple things where that's been a problem. I want to say even like Meta had a similar issue in their OAuth flow. Like it seems to be something that's not handled well, even by experienced development teams and like security hardened products. So
and I think part of that is like the state feels semi-trusted because it is originating from them and getting sent back. In theory, should be getting like a proper degree of validation and stuff too. Like should be getting matched up. Like there are things that could be happening there that do make it somewhat safer to do something like that. But yeah, like it's just adding a lot of complexity. When it comes to meta doing it, like it's possible we've covered some pretty deep meta bugs, in like Meta's auth flow. I think that was that from Jubobs. I think he was the one that I think he's the guy that had some really good write-ups about some OAuth, like the kind of OAuth flow. It was in like their flow for passing on to like Facebook games or whatever. Anyway, I don't remember the exact one where state, but like we have talked about bugs where something in state was getting abused before, because
yeah.
it does feel semi-trusted. It originates from, it's kind of like cookies, but most people understand, or most developers understand now that cookies are attacker control. State feels the same where it's originating, but then the attacker can still modify them if they don't properly validate them. And oftentimes when you have a lot of data in there, they are just somewhat trusting the data that comes back as having been what they sent rather than actually matching it. I do see an ID in this case, and I believe they do comment on there being some checks going on, so there wasn't necessarily nothing going on here, but yeah, I think I've said all I'm going to about the state.
Yeah. And continuing on web issues, we have another post that talks about cross-site post requests without a content type header. So this one has a bit of history and goes into some of that history going back as far as like 2011. So Z, I'll let you get into it.
Oh, those were good days. So this was the bug that they kind of refer to here with Flash Player. That was like one of my favorite little tricks to know about.
I love how you just casually good old days it.
I mean, I wasn't going to until you just mentioned like, oh, the history there. I was more or less planning to skip over mentioning that. But this was one of my favorite things because basically with Flash Player, they are talking about a specific CV here that is a little bit different from this, but basically Flash Player was able to set headers that you couldn't necessarily edit normally, that weren't necessarily, part of like the safe headers that you can enter. One of the things you were able to do was set content type to application/JSON. So you could you could do a CSRF attack using Flash, or starting it from Flash, and it would still use the browser's cookies to make the request. But Flash would be like, oh yeah, and we're changing this header, and it would just work, and it was lovely. You could get a lot of CSRF attacks without actually, or on websites that thought they were protected from it because of this little obscure trick with Flash. So it's just a really fun time to be able to use that, basically. And I definitely had some fun with that bug, or with those issues, for a little while. So anyway, coming on to this one, this is a different attack. Cross-site post request without a content type header. They call out just this edge case I thought was interesting to at least think about, because the content type check for application JSON is one of those things that I've always kind of hated it as a anti-CSRF mitigation, because it just feels super weak. Like, there's no reason why the content type couldn't be something else. Like, there is, like, in the spec for the browser, you're not supposed to be able to set the application JSON, or you're not supposed to be able to set the content type header to anything but a few specific things, like text plain, or like your default like form URL encoded. You're not supposed to be able to do that without passing a CORS pre-flight check and actually saying, like, yeah, these sites are allowed to actually, set that header, and it's cool. Without that, this check is weirdly effective in a lot of ways. And so I guess they came across some code here with Sinatra, which I believe is a framework. I haven't worked with it, but I believe it's a Ruby framework, and they have the code here where it's just if content, or if request.content type and request.content type not equal to application JSON, and that's how they're detecting it. Well, that check is, of course, kind of lacking. What if your request just didn't contain the content type header? Well, it would still go ahead and read that as JSON anyhow. It just wouldn't fall into this check, or it wouldn't fall into the check of actually checking the value because it didn't have the header. But that also kind of comes like, can you send that? And they note here that yes, in fact, you can, using fetch specifically. So using like the XML HTTP request object, that wouldn't work. That would end up having it, but through fetch, there's a trick here, sending the body as a blob. It'll send it out without the content type, but it will still send a post with like content length and everything. I felt like that was a kind of interesting trick here. That's definitely an edge case I could imagine being written in a number of languages. This type of code, if request.content type and request content type not equal to application, that could easily be Python code. So you could easily find this sort of thing in Flask elsewhere, I'm sure. So it's just something worth being aware of. Just being aware of, one, you can't send the request without that header at all. So yeah, I thought it's a cool trick. It's just something to be aware of.
And again, kind of one of those things where you're relying on the docs, where the docs and the specifications don't necessarily match reality, which is the root of a lot of problems in web, I guess.
Sorry, what do you mean?
When you were talking about the content type, like where the content type is supposed to only be set to, like plain or URL, form encoded.
That's only where you can customize it, though. Like, you can only set it manually to like text plain.
But yeah,
because this isn't a case of the spec being
like talking about that. No, I'm not saying it's inaccurate. I'm just saying that relying on that as like a security thing, where you had talked about that being weak. I was just kind of, adding my support to that, I guess.
Okay, gotcha.
Yeah,
because I mean, it's been a weirdly effective mitigation, honestly, because in a lot of cases you just can't do that if you ensure it's there. Like, if you do the positive check of just it's there, otherwise I'm not parsing this, then you also don't necessarily fall into this trap. This is a code pattern I could easily see being written, especially in the era of like writing middlewares that act a little bit generically. You can just look, well, is it this? If it is, do this. And so you can kind of fall through it there. It's a cool trick. I think it's something to be aware of, and I definitely think people can find some bugs abusing that.
Yeah. And on that note, I saw another thing that was a bit of a cool trick on the binary side. So this is almost a little bit of a shout out. I'm not going to go into it too much, but this was a post by Practical Security Analytics that talked about a new AMSI bypass technique. So AMSI is Microsoft's anti-malware scan interface. It's ultimately what facilitates scanning binaries, whether that be through Defender or some other antivirus. And for a while, it seems this was fairly easy to bypass until like September of this year, because for a while you could just like hook Microsoft's API in userland and just patch it and make it useless. But now Microsoft's actually checking the integrity and doing some like signature scanning of their userland APIs. So part of how AMSI is facilitated is through the common language runtime. It'll have this method that reflects the loaded binaries, and it will invoke that method before the PE file is actually mapped to be executed. That method being AMSI scan buffer. The problem is the way they call into that function is they resolve it using get proc address to, get the address for that function. And of course, they have to pass a string of AMSI scan buffer to that function. So what happens if you just modify that string to make it find some non-existent method? Well, of course, the method invocation fails, but because reflective loader has a fail open design, that AMSI check failing just continues to load the binary instead of erroring out. So it's sort of a straightforward bypass, but it's kind of fun in how it works, with it being like a data only attack for manipulating the control flow. We like to talk about that in the context of memory corruption and how you could use data only attacks to bypass mitigations, but using it in this way to bypass like signature scanning and bypassing like malware checking and things is kind of neat too. So, it's a little bit outside of the scope of what we typically cover on the podcast, but I thought it was a neat trick and I figured I'd shout it out for anyone who might be interested, especially people who do like Windows stuff a lot and, where that might be in scope, especially if you're red teaming or something. But yeah, so that's all the topics we had for this week. Like I said, it was a bit of a slow week, not too many topics, and that's kind of typical when you get into December.
Thanksgiving.
October is where all the security stuff is done, and then into November they kind of continue, and then December it's just like burnout time, I think.
Yeah, I mean, definitely Thanksgiving cuts down on
That
the post. There just wasn't a lot that came out this week, at least that I saw. I mean, all of my news sources were a bit dry.
Yeah. So yeah, but we still had some cool discussions, so I'm happy with that. And yeah, unless you have any last minute thoughts, see, we'll wrap it up there.
Yeah, nothing to add.
All right. So as always, thanks goes out to everyone who tuned in. Once again, I'll shill our training a little bit if you think it's interesting or think you might have friends who would find it interesting. I'll link it out to them. And with that said, we'll see you next week.